Hi, this is Mr. Nazarian. Our lesson objective today: I can solve real-world problems involving volume of rectangular prisms. 5th grade standard, measurements and data, C5b. Parker's pool is filled with 270 cubic meters of water. The base of the pool is 15 meters long and 9 meters wide. What is the height of the water in Parker's pool? So let's remind ourselves real quick here. What is the formula for finding volume of a rectangular prism? You've got that down. It is volume equals length times width times height. So typically what we've been working with volume is we've usually been given the information for the length, the width, and the height of the rectangular prism, and then we solve for volume. But in the case of this problem, we are not given the height. That's the question. What is the height? What we are given is the length, the width, and the volume, right? The total amount of water that fits in that pool. So we have a pool that holds 270 meters cubed, and the length is 15 meters, the width is 9 meters, but the height is what we need to solve for. So as we look at this problem, first, the volume's just sitting here. The volume is not going to change, right? But usually what we'll do to find that volume is we'll multiply length times the width times the height. Well, we can't quite do this part yet because we don't know what it is, right? But we do know the length and the width, so that these two dimensions we can multiply, and that's our first step. So what would 15 times 9 be? Okay, I'm going to do mental math here and do 10 times. I'm going to break this 15 into 10 and a 5. 10 times 9 is 90. Half of that, right? 5 is half of 10. So half of that would be 45. The 90 and the 45 together is going to give me 135. So now, as I'm looking at this, the length and the width, remember, as a reminder here, that length and width gives us the base. So another formula for volume you could say is volume equals base times height. So the base of the pool, what's on the the floor of the pool, is I should say actually here 135 square meters, and we need to multiply that times the height to find the total volume here. So the base times the height. So what we know is that the volume is 270 meters cubed. The base, which is the length and the width, is 135 meters squared. And we need to multiply it by something here. This is what we don't know. So really all that we need to do is think this 135 times h equals 270, right? So 135 times what will give us a total of 270. 135 times what equals 270. Go ahead and solve for that. All right, so a couple different ways that you could do this, right? If we know that h times 135 equals 270, that means 270 divided by 135 would give us h, would give us the height, right? Because of fact families, because multiplication, division are inverse operations. I'm going to, I could think of that in that way, and I could do 270 divided by 135 and reach my answer. Also, I could just look at this and just kind of think about the relationship in numbers and think, well, I know that it's going to be some multiple of 135 that's going to give me 270. It's not the first multiple, because that would be 135. The second multiple, that's a pretty good guess, right? Because we're looking at 100 something, and over here we're looking at 200 something, right? Well, if I tried that, right, and I did 135 times 2, then, and I used the standard algorithm, I would find that it equaled a total of 270, right? Or if I could just think mental math, I think, well, 2 groups of 100 is 200, 2 groups of 35 is going to give me 70. So the height, therefore, is a height of 2. So we have 270 meters cubed is the volume times 15 times 9 times 2. That gives me the height there of 2 meters. So that's what we're going to work on more on tomorrow, just working on, and it's going to vary, but different word problems involving volume. All right, see you then.